Now, we want to talk about some applications for the differentiation. The first application, which is finding the extrema on an interval. So before that, let's review some definitions we have learned in the pre-calculus. The absolute or the global maximum, which means the largest f values on the interval, right? Absolute or global minimum, which means the smallest value of the function on its domain. So both are called absolute extrema or global extrema. Local or relative maximum, that means nearby the point, which is the maximum, the largest value. The local or relative minimum means nearby that point, which is the smallest value. Both are called local or relative extrema. Okay, so now we use this graph to help you to review these definitions. So this is the graph for the function y equals f of x. And the domain, which is from a to e, this is the domain. Okay, so from this graph, this is the highest point, right, on the domain from a to e. So this is called, the values of this point, which is called absolute maximum or global maximum. So we write as absolute A, B, S maximum. So that means absolute maximum. Okay, so this is the absolute maximum. And which point is the lowest point? I think it's here, right? At the end point. So this is called the global minimum or the absolute minimum. So this is the ABS, means absolute minimum, min. Okay, so now let's look at the local extrema. What about this point? Nearby this point, let's look at this blue part. This is the highest point, which means it has the largest value. So it's called local, the values, f values of this point is called the local maximum. What about this point? Nearby this point, you can see the blue curve. This is the lowest point, right? This is the lowest point, so this would be the local minimum. This point has the value local minimum. What about this point? Nearby this point, this is called local maximum, right? So this point is the local maximum, is also the absolute maximum. What about this point? No, we don't know the other side, on the right side of E. So it's neither the local maximum or local minimum. What about this point? This point also, because we don't know the behavior of this function on the left side of A, so it's not a local minimum. So this is the quick review for the local maximum, local minimum, absolute maximum, and absolute minimum. So now, in this part, we will talk about how to locate the absolute maximum and absolute minimum on our closed interval for our continuous function. So before that, we will introduce a topic, a definition which is called a critical point. You will see this definition throughout this part, this chapter. Now let's look at the definition. So we say x equals c, c is a constant, in the domain of a function f is called a critical point. So sometimes we call the critical value or critical number. If either f prime, the derivative of f evaluated at c equals 0, or the derivative of f does not exist. Okay, so this is the definition. So this c should be in the domain. Then either the derivative of f at c equals 0 or does not exist. Then we say this x equals c, this c number c is called a critical point or critical value. So now let's use an example to help you to understand how to find the critical values. So f of x equals x cubed minus 2x squared plus 1. Okay, so this is the function f. So we want to locate the critical point or the critical values. So from the definition, we have to take the derivative, right? So now let's look at the derivative. What is the derivative of f? So this would be 3x squared minus 4x plus 0. So we need the derivative, this critical value should make the derivative to be 0 or to be undefined. That means that does not exist. But here, this derivative is a polynomial, so it's defined everywhere from negative infinity to infinity. So there is no number to make this derivative not exist. But we have some numbers to make this derivative to be 0. How to find that numbers? We just set f prime equals 0. So then solve this equation. 3x squared minus 4x equals 0. So now let's factorize it. We take some common factor x out. 3x minus 4 equals 0. So x equals 0, or x equals what? 4 over 3, right? So you have two critical points or critical values. Okay. So now let's look at another definition. Another example. F of x equals the absolute value of x. Also, the graph for this function is given by this one, right? And we know that at this point, the derivative does not exist because this is the sharp corner or sharp point. So this point has the x equals 0 of this at this point. So x equals 0 is the critical value or critical point, because since f prime at 0 does not exist. Okay, you can see my previous lectures to see why this one, the f prime of 0, does not exist.